Assalamu alaikum wa rahmatullahi wa barakatuhu. So, we have started with our third unit, isn't it? I hope everyone has seen the video of in which you have seen test of divisibility or rules of divisibility, isn't it? So, what is the need of those tests is if any number is given to you, you can do some test, okay, whether it is divisible by that particular or number or no, right? So in the video you had seen two for divisibility tests for 2. So do you remember what was that? How do you find that your number is divisible by 2? So you are going to check your units place, that is ones place. Oh, and ones place, if it is even number, that is if it is 0 1 sorry 2 4 6 8, okay, at the units place or ones place, if I take number something like this big number, so if you need to just check at the units place whether if it is a even number, this digit, it is even number or no. So if it is even number, then it is divisible by 2, isn't it? It's so easy. So all you need to do your division, and after division if you get remainder 0, then you will say that it is divisible by 2, isn't it? So instead of going so long, sometimes it will be asked, by using your divisibility test, find whether in the given number is divisible by 2 or no, 3 or no. Okay, so let me now what about 3? What was the test rule for 3, divisibility for 3? Yes, so for 2, then if number ends with an even number, then you that is ones place, or if it is ending with the even number, you say it is divisible by 2. Now tell me about 3. Yes, 3, what you'll do, you will add continuously, you will add and find the digital rule, sorry, digital root. Okay, so if my given number is this, if I want to know whether it is divisible by 3 or no, what I will do, I will add all these numbers, 7 plus 5 plus 3 plus 4 plus 5 plus 0 plus 2 plus 0. Okay, then what is the addition? 7 10 15 16 17 18 19 24 25 26. So I got 26 by adding all these. So then again I will add 2 plus 6. You will add until you get a single number, okay, single digit, not number, single digit. So you have 2 digits here, 26. So again add the 6 7 8. So you got 8. So this 8 is not divisible by 3. It is not there in 3 table, isn't it? Like this. So you can say that then the 7 5 3 4 5 0 2 0 is not divisible by 3. Okay, okay, so what is your digital root? So digital root is you are going to add, okay, by repeated addition you're going to get some, that is summing of digits, you will get some digit. Over that particular digit you call it as digital root. So digital root of this number in this case what we got is, it is 8. Okay, digital, if maybe I can ask you in test, digital root of this number is what? It is 8. It is not 26. Okay, digital root is a single digit number. Okay, all right. So I hope 2 and 3 it's very clear to you all, isn't it? Okay, I have taken one example here, digital root of 129. If I want to know what is the digital root of this, what you will do, add all the digits, 1 plus 2 plus 9, here I did, so it is 12. Again this is not a digital root. Now again you need to add 1 as 1 plus 2. Okay, so digital root of 129 is 3. Alright, This is how you are going to find your digital root, or what is a digital root. Whenever is asked, you need to follow this process. Okay, I hope till here it's very clear to everyone about how the number is divisible by 2 and how the number is divisible by 3. It's totally clear, isn't it? Okay, what about 4 now? So in for 2, you can easily remember. For 4 now, for 2, what we did, we had checked the number at units place, isn't it? So for 4, what you will do, you will check the number in last 2 places, that is units place and that is ones place or and tens place. Okay, let me take the same number 75345020. Okay, so we are going to check the last 2 places of the total number. Okay, the 2 digits, if it is divisible by 2, then you can say that this is your divisible, this number is divisible by 4. Okay, either it should be divisible by 2, or that is 2 places can be 0. If the last 2 places, that is units place and tens place, if it is 0, then also that number is divisible by 4. Alright, okay, so tell me whether this is divisible by 4. This total number, it is divisible by 4. Yes, because your units and tens place, you have 20. Okay, this 20 is there in 2's table, isn't it? 2 tens is 20. Or directly you can see this 20 is in 4 table, right? 4 5s is 20. So the last 2 digits, if you just check it, if it is divisible by 2 or divisible by 4 itself, then you can say the whole number is divisible by 4. Okay, and if suppose if it was 0 0 here, okay, immediately by looking at this number, you can say at units and tens place, if you look at this number, you can easily say that this is divisible by 4, because it is a rule that if you check in units and tens place, if that number is divisible by 4, or if it has 0 0 in units and tens place, then the whole number is divisible by 4. Hope I'm very clear about this. It's very easy. For 2, you are going to check for only units place. For 3 is what? You need to find your digital root. Okay, and then again for 4, it is you need to check the units and tens place. Okay, if that number, if the number formed by those 2 digits at units and tens place, if it is divisible by 4, okay, or if units and tens place, if it has 0 0, then also the whole number is divisible by 4. Okay, okay, now let's move on to the next number, that is 5. It's very easy how for the divisibility test of 5. So what if your number is at ones place, if it is 0 or 5, you can say that the whole number is divisible by 5, isn't it? It's very easy. Now let's see after 5, 10 also. So 10 is again easy. You are going to check the units and ones, that is ones and tens place, or if you have only at ones place 0, then it's where you can say that 10 is that total number is divisible by 10. Okay, all right. So at see, whenever this point is also important, the number which is ending with 0 or 5 at units place, you can say that it is divisible by 5, isn't it? And the number which is ending at units place as only with 0, then you can say it is divisible by 10. Alright, so what does this mean? What about 2? 2 is at units place, if it is 0, then you'll say that is divisible by 2, isn't it? So the numbers, okay, which are divisible by 10, they are divisible by both 5 and 2. For 10, what happens? It is at units place, if it is 0, then you say it is divisible by 10. So it's nothing but that particular number is divisible by both 5 and 2 table, isn't it? Let me take one example. If I take one number as 50010, okay, so first I will check this number whether it is divisible by 10 or no. At units place I am going to check. Okay, so units place it is 0, so obviously this whole number is divisible by 10. Okay, now is this number divisible by 5? For 5, what you'll see again in units place, if it is 0 or 5, then it is divisible by 5. So this number is divisible by 5, isn't it? Now what about is it divisible by 2? Yes, of course, because at units place it is 0, so it is also divisible by 2. So the number which is divisible by 10 will also be divisible by both 5 and 2. Any number, okay, if you take any number which is divisible, if it is that particular number is, if it is divisible by 10, you can say that it is divisible by both 5 and 2. Okay, so we have done with 5 and 10. Okay, after 5 let's go for 6. When you come for 6, see 6 6 have multiples 2 and 3, isn't it? 2 cross 3. For 10, what we had seen, 10 we have multiples 5 and 2, right? So 5 2s is 10, isn't it? Like this, 3 2s is 6. So for 10 multiples were 5 and 2. So the number, any number which is divisible by 10, that means that number can be divisible by both 5 and 2. The same case you can see for 6. Okay, so any number which is divisible by 6, that means it is divisible by both 2 and 3. Okay, or you can say see, if you check in this chart, okay, what I'm doing is I'm just taking all the multiples of 2, okay, and I'm crossing it with a red pen like this, a red ink. So 26, 28 comes under 2 table, 30, then 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 50, sorry, 54, okay, and so on. Now let me circle the numbers which are in the 3's table, okay, multiples of 3. So I'm circling your number multiples of 3, okay. So this will be 50, 1, 2, 3, 51, okay, 54, then 57 comes under 3 table, and so on. Alright, now it says just observe in this table, okay, number this thing block. See, the numbers which are divisible by 6, okay, you'll that is you have both 2 and 3 are divisible, okay. For example, you have 6, so 6 is divisible by what? 2, 2 3s are 6, right? And also 3, that is 3 2 6. Okay, let me check the next here. This number 6 was there in the 6 table. Now next number will be with both the blue and the cross and the circle is 12, isn't it? So 12 is there in 2 table, isn't it? It is divisible by 2. And what about 3? It is divisible by 3. If you can take digital root, 2 plus 1, it will be how much? 3. So this 3 is divisible by 3. So this 12 is divisible by 6. Okay, so any number which is divisible by both 2 and 3, then that number is divisible by 6. Okay, look again, for 14 is there in 2 table, but this is not there in 3 table. Okay, so that is why you will not say that this is divisible by 6. Okay, and 15, if you go for 15, 15 is there only in 3 table. This is not there in your 2 table, isn't it? So you will not say that this is divisible by 6. Okay, let's move to 18. See, look at 18. 18 is what? It is divisible by 2 and also divisible by 3, isn't it? You have in 3 table 18, right? and also in 2 table you have 18, so 18 is there in your 6 table, that is it is divisible by 6 also. So numbers which are divisible by both 2 and 3 are divisible by 6. Okay, so let me take one example. I have 8430. Okay, I want to check whether this is divisible by 6 or no. So what I will do first, the rule is that this number should be divisible by 2 and 3. Check for 2. Since at the units place it is 0, this number is divisible by 2, isn't it? It is divisible by 2. What about I need to check for 3. So for 3, how you'll go? You need to find digital root. So 8 plus 4 plus 3 plus 0 is how much? 9, 10, 11, 12, 13, 14, 15. You got 15, but this is not a digital root. You need to take this now as 1 plus 5. So this is 6. This number is divisible by 3. So this number is divisible by 3 also. So when 2, it is divisible by 2 and also 3. That is why you can say that it is divisible by 6. Okay, that is what I have explained here. Okay, digital root we got 6, which is divisible by 3, and also since it is at one's place it is 0, it is divisible by 2. So we can say that 8430 is also divisible by 6. Okay, let's move on to the next number, that is 8. And what about 8 now? What do you think? So for 2 we had seen for only units place. For 4 what we did, we had checked for units and tens place. For 8 you will check for units, tens and hundreds place. Okay, you remember the sequence. So you are checking for divisibility of 8 for the last 3 digits. Okay, 7, 6, 5, 1, 2. So if you check this 3 digits, if it is divisible by 8, 5, 12, it is divisible by 8, how much? 64 thus. So you will say that 7, 6, 5, 1, 2 is divisible by 8. Simple. Or if this is the units and tens place, if it is 0, you can directly say that this is divisible by 8. Okay, this is the rule for your divisibility of 8. Okay, just remember all your even number 0, 4, 8 for the 2, 4, 8 for 2 you will check for units place. Okay, and for 4 you will check for units and tens place. For 8 it is units, tens and hundreds place. Okay, easy to remember. Okay, let's move on to the 9 number. Now your 9 number is similar to your 3 number. Okay, so that is 3 3 is 9, isn't it? So what you do, you will go for digital root again, but you will not take, see, you will add all the numbers given. Okay, and then you will check whether that digital root we got, it is divisible by 9 or not. Okay, for 3 you will get single digit of number, but for 9 you can have 2 digits of number. Okay, so understood. So 3 and 9 you have similar rule. The number given, you will add those numbers. Okay, each digit, that number digits you will add, and the result what you get, you're going to check whether it is divisible by 9 or no. If it is 3, for divisibility test for 3, you will check that digital root whether it is divisible by 3 or not. Okay, so 3 and 9 it is similar, and you have divisibility for test 11 for 11. We will do this in the next video. So anyway, so I'll just revise one more time. Starting from 2, 3 is, you'll find digital root. Okay, 3 is for units place, you'll check, 2, and then 4, 5 is again easy. 3, 9 you'll go for digital roots. Okay, for 5, 10 you will check for the 0 for 10, and if it is for 5 you will check for the units place 0 or 5. Okay, and 4, 5, 6 is what? 6 you will see whether 2 and 3, whether the number is divisible by 2 and 3, then that is divisible by 6. Okay, 2, 3, 4, 5 is finished. 6 is this. 7 you don't have. 8 is what? You will check units, tens, hundreds place. Okay, 9 is digital root, just like 3. Okay, 10 is finished. Okay, 11 is left out. We will do this in the next video. Okay, I hope it's clear and easy to remember. You need to remember these rules. Okay, and we are going to do the problems on by using these rules. Okay, in our Zoom meeting, inshallah. Until we meet again, assalamu alaikum wa rahmatullahi wa barakatuh.